Imagine you're building like a state-of-the-art vault to hold your most valuable possessions.
Okay.
You use the thickest steel you can find, you install these complex biometric locks, set up a perimeter of laser sensors, but then, without really thinking about it, you just hand the master blueprint and the override codes to the person installing your security cameras.
Right. Just to speed things up.
Exactly. Just because it makes the installation go a little faster.
Yeah.
And that paradox, I mean, that is exactly the landscape we are walking into today.
Yeah, the irony of modern infrastructure is really hard to ignore right now. We spend millions building up this massive perimeter only to, centralize all of the systemic risk on the inside.
We really are. And welcome to the deep dive, everyone. Because today we are exploring 3 pieces of intelligence that, when you put them together, they show this massive shift in how our digital trust boundaries operate.
It's a pretty stark picture.
It is. So we have threat intelligence from Mike Kosak. He's a director at LastPass, warning about the inevitable AI data breach.
Which is a huge topic right now.
Oh, absolutely. Then we have a breaking report on the catastrophic March 2026 cyber attack on the medical tech giant Stryker. And finally, we're looking at some technical documentation from Swimmage Rapid Recovery on how to essentially resurrect an enterprise from the dead.
Which is fascinating tech.
It really is. So the mission for our deep dive today is to connect these dots for you. We want to understand the hidden value of the data you are giving away, how attackers are bypassing traditional malware to get to it, and, well, what happens when an organization's only choice is to press a massive global reset button.
Yeah, and if we start with the data itself, the expansion of the attack surface is just unprecedented. But I think more importantly, the psychological nature of what we are digitizing has fundamentally changed.
Okay, let's unpack this. Because Kosak's piece in Tech Radar points to a recent security breach at a third-party data analytics vendor for OpenAI.
Right, I remember reading about that.
Yeah, and it exposed API users' names, email addresses, and browser details. Now, on the surface, losing your browser details or even your email doesn't sound like a world-ending event.
No, I mean, that happens all the time in standard breaches.
Exactly. But Kosak argues this is a massive shot across the bow.
Well, you have to look at the historical parallel Kosak draws to really understand the severity here. Think back to the late 2010s.
Okay.
Sophisticated hacking groups realized that attacking 1,000 individual companies was, terribly inefficient.
Right. Too much work.
Exactly. So they pivoted to attacking the cloud service providers hosting those companies, breach the cloud, breach everyone inside it.
Just a pure economy of scale.
Precisely. Kosak is warning us that AI companies are the new cloud service providers.
Oh, wow.
Yeah, but instead of just hosting static databases of customer addresses or encrypted passwords, they are ingesting a dynamic, unfiltered stream of human thought. Proprietary code, unvarnished corporate strategy.
I keep thinking about modern AI platforms as almost like digital confessional booths.
That's a great way to put it.
I mean, if you're listening to this and you've used a chatbot today, just think about what you asked it. People use these platforms to troubleshoot complex, proprietary coding problems for their jobs, just pasting in raw back-end architecture.
Or they use them to summarize highly confidential legal documents because they're in a rush before a meeting.
Exactly. Or they use them for therapy, asking deep mental health questions they might not even ask their actual doctor.
And the data Kosak brings in from Harmonic shows exactly how porous the corporate perimeter has become because of this.
What did they find?
They found that 45.4% of sensitive company data submissions into AI apps actually came from personal accounts.
Wait, almost half.
Yeah. Employees are intentionally bypassing corporate firewalls. They encounter friction with internal sanctioned IT tools, so they just pull up a public AI model on their personal phone to get the job done faster.
Which introduces the concept of shadow IT on just a massive scale.
Exactly.
Because when Varonis reports that 99% of organizations currently have sensitive data exposed to AI tools, they're talking about this exact shadow usage.
You hit the nail on the head. Your IT department can't secure a workflow they don't even know exists.
Right.
It means the concept of a closed corporate network is, well, functionally dead. And the threat isn't just that someone steals the foundational AI model's source code.
Right. It's the inputs.
Yes, the sheer staggering volume of customer-provided context being fed into those models every second. It's a real-time feed of vulnerabilities.
But with the billions of dollars pouring into the AI sector right now, shouldn't these platforms be built like impenetrable fortresses? I mean, security should be top tier.
That is the logical assumption, but it ignores the current development culture, which really brings us to the structural issue Kosak highlights.
Right.
He uses a term that perfectly captures the industry's current mindset. He calls it vibe coding.
I have such a love-hate relationship with that phrase. What does vibe coding actually look like under the hood?
Essentially, it refers to developers relying heavily on AI to generate code for them. They're prioritizing rapid implementation and, a cool user experience over rigorous foundational security architecture.
So it's like an architect designing a beautiful glass-walled skyscraper based purely on how the lobby will look on social media,
That's exactly it.
but completely forgetting to calculate if the internal steel beams can even support the weight of the building.
Yes. The developer accepts the functional output from the AI without truly understanding the underlying security mechanics.
And Kosak points to a platform called Moltbook as a prime example of this.
Yeah, Moltbook is a perfect case study.
Because after it was rapidly adopted, massive vulnerabilities were independently discovered by the security firm Wiz and by the researcher Jameson O'Reilly.
Right, because in the rush to implement new large language model features, developers behind platforms like Moltbook often skip basic security hygiene.
Like what kind of hygiene?
Things like input validation or role-based access controls. They just bolt the AI feature directly onto the back-end database to get it working quickly.
And Wiz documented how this allows a threat actor to just easily manipulate the AI's prompts to bypass the user interface entirely, right?
Exactly. They can just dump the entire back-end database. So you combine incredibly fast, insecure development with the most sensitive human and corporate data imaginable.
And you create the ultimate honeypot.
The ultimate honeypot.
Kosak actually makes a chilling point about the extortion potential of that honeypot.
No, he does.
He specifically mentions people in the military, the intelligence community, or first responders.
Right, high-stress environments.
Exactly. Where seeking official documented therapy might carry a perceived stigma or actual career repercussions. So they turn to a chatbot, assuming their 2 a.m. conversations about operational stress are completely anonymous.
But if that data is breached and tied back to their personal email or browser details, like in that OpenAI third-party vendor incident, the anonymity just vanishes instantly.
Verify.
It is. A threat actor now has a searchable database of the psychological vulnerabilities of intelligence officers or corporate executives.
The leverage gained from that kind of highly specific personal data goes so far beyond traditional financial extortion.
Absolutely. It's a whole new ballgame.
Okay, here's where it gets really interesting. Because if our AI habits are creating this perfect, centralized honeypot of data, the obvious question becomes, how are hackers actually getting inside the network to steal it?
Right.
Because if you look at modern attacks, they aren't always breaking down the front door with flashy zero-day malware anymore.
No, the tactics have shifted dramatically, and the March 2026 attack on Stryker provides a textbook masterclass in this new methodology.
Stryker is a global medical technology giant. They manufacture surgical equipment, neurotechnology, orthopedic implants. I mean, they pull in $25 billion in revenue.
A massive target.
And on March 13th, they suffered a catastrophic global disruption to their Microsoft environment.
Total blackout.
The operational impact was immediate. Order processing, manufacturing, shipping, all halted. In Ireland, which is Stryker's largest hub outside the U.S., support staff and engineers were literally sent home.
They couldn't do anything.
They had to rely on a WhatsApp group chat just to coordinate when it was safe to return to the building.
Which is wild to think about. Your entire enterprise infrastructure goes dark, and a multi-billion-dollar company is reduced to checking their phones on the couch.
Right. But the scale of the disruption aside, the technical mechanism is what I want to try and figure out here.
Yeah, let's get into that.
Because Stryker explicitly stated in their media release that no malware or ransomware was detected during their investigation.
That's the key point.
If there is no malware, they can't be infecting the machines. So wait, are they just logging in as an administrator and manually pressing delete on 200,000 individual devices?
Yeah.
How on earth do hackers wipe over 200,000 devices without malware?
Well, you're on the right track regarding the administrator access, but it's much more automated and frankly insidious than manually deleting files. Okay.
The industry calls this living off the land. The attackers didn't need to bring their own bombs to the building because they found the building's demolition switches and just flipped them.
So let's break down those demolition switches. According to cybersecurity blogger Brian Krebs and some unverified insider reports, the attackers abused Microsoft Intune.
Right. Now, Intune is a Unified Endpoint Management Service, or UEM.
Okay.
Its entire architectural purpose is to secure and centrally manage an organization's devices, whether that's Windows laptops, MacBooks, iOS phones, or Linux servers.
The omnipotent tool.
Exactly. It's what the IT department uses to push software updates, enforce security policies, and crucially, remotely wipe a device if an employee leaves a laptop in a coffee shop.
Oh, so the hackers essentially stole the keys to the IT department's management software.
Yeah.
They found the legitimate wipe device button and used the tool's own automation to press it 200,000 times simultaneously.
Exactly. If we connect this to the bigger picture, they weaponized the exact tool designed to keep the network safe. That is just brilliant in a terrifying way.
It is. Security software, by definition, requires the highest level of administrative privilege to do its job. It has to be able to see every file and change every setting.
Right.
So if a threat actor compromises the credentials for a global admin account, perhaps through a stolen session token or bypassing weak multi-factor authentication, they become the administrator.
And then they just use the system's own APIs against it.
Exactly. They can use Microsoft's own Graph API to script a remote wipe command to every single registered endpoint.
And because the system recognizes the commands as legitimate administrative actions coming from Intune, the traditional anti-malware tools on the laptops don't flag it.
Right. To the laptop, it just looks like the IT department is doing its job, albeit in a very destructive way.
Wow.
The endpoint protection tools are literally programmed to obey the UEM. When the master control system says, format the drive, the laptop complies. It is an architectural vulnerability of having too much centralized power.
We also need to talk about who is taking credit for this, because it highlights the complex geopolitical layer of modern cyber warfare.
Yeah, the attribution is always tricky.
The Security Week article outlines this, and we want to just lay out impartially what the sources are reporting here. A group calling itself Handala publicly took credit for the attack.
Yes.
They claim to have stolen 50 terabytes of data from Stryker before issuing that massive wipe command.
Right, and Handala publicly portrays itself as a pro-Palestinian hacktivist outfit. They claim their motivations are tied to the geopolitical conflicts in the Middle East, specifically targeting organizations they perceive as aligned with Israel or its allies.
Right.
They frequently use Telegram and X to post their claims and share what they present as evidence of their successful breaches.
But the cybersecurity community's intelligence paints a very different picture of who is actually behind the keyboard, right?
Yes. While Handala claims to be an independent activist collective, the consensus among cybersecurity researchers, as reported in the article, is that the Handala persona is just a front.
A front for who?
Researchers widely regard the group as a cover for Void Manticore, which they identify as a sophisticated, state-sponsored threat actor from Iran.
Okay.
Specifically, threat intelligence firms believe this group operates under the direct guidance of Iran's Ministry of Intelligence and Security.
So we have the group's public claims of grassroots hacktivism on one side, and the cybersecurity community attributing the attacks to Iranian state-sponsored operations on the other.
Correct. But regardless of the true origin, their methodology is clear. Phishing, massive data exfiltration for extortion, followed by highly destructive wiper attacks using the victim's own infrastructure.
Which brings us to a terrifying realization for enterprise organizations.
It really does.
When your own security tools are weaponized against you and state-sponsored or highly sophisticated actors are turning your entire network to digital ash, the traditional defense mechanisms have already failed.
You're no longer preventing an attack at that point. You're purely surviving one.
So what does this all mean? That brings us to the final piece of the puzzle.
Yeah.
How do you actually bounce back from zero?
Right.
Your devices are bricks. Your manufacturing has stopped. You're staring down a multi-million-dollar disruption. And the Swimmage documentation notes that ransomware and wiper attacks cost the global economy over $6 trillion annually.
It's an astronomical figure, because when you lose 200,000 devices simultaneously, the sheer mathematics of recovery become the primary existential threat to the business.
You can't just rely on cloud backups for a total network failure of that size.
No, absolutely not.
Let's do the math on that. If you have 200,000 devices, and a standard Windows Enterprise image is what, around 20 gigabytes?
Easily. Often more once you include the necessary applications and security stacks.
So you are trying to push roughly 4 petabytes of data across a corporate network that is likely severely degraded, locked down for forensic analysis, or entirely offline.
Exactly. You can't just download a new operating system from the cloud for every laptop.
The bandwidth constraints alone mean your company is offline for months.
You cannot use a centralized cloud backup to fix a massive decentralized wipe. It literally, physically takes too long.
This is where tools like Swimmage Rapid Recovery come into play.
Yeah, this raises an important question about proactive resilience versus reactive panic.
Right, because reading through their technical documentation, it sounds a bit like a combination of a digital time machine and an automated hazmat team.
That's a good analogy.
It quarantines an infection while simultaneously rebuilding the house around it. But mechanically, how does it achieve a rebuild if the operating system is already compromised or actively being wiped?
The mechanics are actually quite elegant. Swimmage isn't something you download after an attack. It's an endpoint management add-in. But the crucial distinction is that it's installed preemptively.
Okay, so it's already there.
Yes. It lives locally on the hard drive, completely dormant, until a disaster triggers it. When an Intune-style wipe command hits or a ransomware payload executes, Swimmage initiates a zero-touch rebuild.
Wait, but if it's on the same hard drive as the malware, how does it protect the user data while formatting the drive?
So it modifies the boot record to instantly reboot the machine into a secure, isolated pre-installation environment, usually a customized Windows PE.
Okay, Windows PE.
Right. From there, it doesn't try to copy your files to a server because the network is dead anyway.
Right, no network.
Instead, it isolates the user partition at a hardware level. It uses hard links to essentially lock the user data, profile settings, and critical files in place on the drive.
Hard links, okay.
Yeah. Then it aggressively formats the OS partition. It blows away the malware, the corrupted registry, everything. It lays down a known good, pristine base image from a secure local cache, and then seamlessly reconnects those protected user hard links.
Oh, wow. So the data never actually moves across a network.
Ooh.
Or even across the physical disk, really.
Exactly, and that explains the speed. Because the data isn't migrating, the physical time to rebuild the system is reduced strictly to the time it takes to write the fresh OS image.
That's incredible.
Swimmage CEO Kyle Haraldson notes in the documentation that companies are often forced to pay massive ransoms simply because they have absolutely no other way to recover in a reasonable time frame.
Right.
With a local rebuild mechanism like this, systems are rebuilt to full functionality usually within an hour, eliminating the malware and saving millions by preventing business interruption.
It's purely an economic calculation at that point.
100%.
Companies don't pay ransoms because they want to trust criminals. They pay because the math of being offline for 3 weeks and bleeding revenue is so much worse than the math of the ransom demand.
It shifts the extortion power dynamic entirely.
Right.
Because if a hacker says, pay me or your computers stay locked forever, and you can just trigger a local zero-touch rebuild that formats the drives and restores the entire global network over a lunch break, the attacker loses all their leverage.
They have nothing on you.
Exactly.
It's incredible to trace the conceptual journey we've taken today.
It's a lot to process.
It really is. I mean, we started by looking at how our data has never been more valuable or centralized, thanks to our rush to feed our deepest corporate and personal secrets into these AI honeypots.
Driven by that culture of vibe coding?
Right, just ignoring foundational security for speed. And then we saw how hackers have never been more clever. They don't even need to write zero-day malware anymore. They are literally weaponizing our own security management tools, like Microsoft Intune, to wipe hundreds of thousands of devices with a single legitimate command.
Just turning our IT infrastructure against us.
And finally, we explored how the only way out of that mathematical trap is preemptive, rapid recovery armor that rebuilds the system locally.
It is a rapidly evolving ecosystem, and the attack vectors are only going to become more intertwined.
Yeah.
Actually, before we wrap up, I want to leave you with a final thought to mull over, kind of connecting the dots between Mike Kosak's warnings about AI data breaches and the reality of the Stryker attack.
Oh, please, take that a step further for us.
Well, we know AI platforms are vulnerable honeypots of deeply personal, unvarnished human data.
Right.
And we know hackers can compromise internal management tools like Microsoft Intune to wipe or lock systems at scale.
Yeah.
What happens when these two threats converge?
Oh, man.
Imagine a near-future scenario where a threat actor breaches an enterprise AI assistant. They don't just steal the data to sell it, they run an analysis against the chatbot logs to find the company's most psychologically or professional vulnerable employees.
Based entirely on their private late-night drops.
Exactly. And then, armed with that highly personalized extortion material, the attackers use the company's own automated endpoint management software to autonomously target and lock only those specific employees out of their devices.
Oh, wow. That is incredibly dark.
It is no longer a blunt force wipe of 200,000 machines that triggers a massive global corporate response. It is highly targeted, personalized, automated extortion, executed silently through the company's own trusted infrastructure.
That takes the concept of the inside job to a completely different psychological level.
It really does.
And brings us right back to that Walt blueprint we talked about at the beginning. We are building incredible, powerful technologies, but we have to be so careful who holds the override codes and what kind of data we are putting inside the vault to begin with.
Absolutely.
So if you are listening to this, take a moment today to understand exactly how your company's endpoint management is secured. Check your company's AI use policies, and seriously, think about your own personal risk appetite before you type your next prompt into an AI model.
Good advice.
Thank you for joining us on this deep dive. We'll catch you next time.